You flush a toilet in the busy retail store, the water disappears, and, well, you probably never think about it again.
Right. I mean, why would you?
Exactly. We just treat it as a given. But behind that tiled wall is this massive, highly pressurized grid, basically balancing hundreds of gallons of water in a really precarious state of equilibrium.
Yeah, it's a lot more delicate than people realize.
It really is. And so today, we are diving into an unpolished, totally raw instructional video from a commercial plumber. Specifically, we've got a transcript from the YouTube channel How to Plumbing to see what actually happens when that grid fails.
Oh, this is such a great source.
It is, right? Our mission for this deep dive is to look past the grease and the grit of a seemingly mundane task, replacing commercial toilet flush valves, to uncover the high-stakes strategy, the hidden engineering, and honestly, some surprising real-world hazards of commercial plumbing.
It's the perfect lens for examining invisible infrastructure because, we really only notice these systems when they break down.
Yeah, nobody notices a working toilet.
Exactly.
Yeah.
And in a commercial setting, a plumbing failure is an immediate threat to the entire operation of the building. I mean, you aren't just dealing with a puddle on the floor. You are dealing with potential code violations, store closures, and just massive logistical headaches.
Okay, let's unpack this. Because the plumber in our source is replacing 4 commercial flush valves, they call them stops, in a men's restroom located inside a live retail store.
Right, an open store.
Yeah, customers are shopping. And the stakes are incredibly high from the very first second. I mean, the plumber isn't just fixing a leak. They're literally racing a ticking clock based entirely on the building's infrastructure layout.
And that's because the main water cutoff valve for these 4 men's room toilets doesn't just operate in isolation.
Right.
It also controls the water supply for the women's restroom right next door.
Wow, so it's all connected.
Yeah, so shutting off that one local valve disables the sanitation infrastructure for the entire retail floor.
That is, I mean, the moment you turn that wrench, every customer and employee in the store loses bathroom access.
Yeah.
You can't just casually cut the water, tear down the old hardware, and then, sit on the floor opening cardboard boxes to figure out how the new parts fit together.
No, absolutely not. Extended downtime in a retail environment like that causes massive business disruption.
So because the water can't be off for long, the plumber has to have a really specific method for beating the clock, right?
Exactly. The plumber's entire strategy is dictated by this infrastructural bottleneck. The whole goal is just minimize system downtime.
Right.
So the transcript refers to their specific method as doing a prefabrication.
Right.
They essentially run the job backwards.
I love this part. It's like a high-end chef's mise en place, right? Having all the vegetables chopped and pans out, all the sauces prepped before the dinner rush even begins.
Yeah, that's a great way to look at it.
Or, I mean, looking at it mechanically, it's like a Formula One pit stop.
Oh, for sure.
You don't pull the car into the pit box and then send a mechanic to the back of the garage to, rummage around for the right tires.
No, you'd lose the race. So instead, the plumber unboxes all 4 of the new flush valves and preassembles them completely while the water is still on.
Well, the bathrooms are still fully functioning.
Exactly. They lay out the tools in perfect sequence. So when the track, meaning the main water line, is finally closed, they swap out all 4 units in one lightning-fast coordinated motion.
That's wild. So all the actual work happens before the water's even off.
Yeah, the preparation phase takes up the bulk of the labor time, which leaves the actual system downtime at an absolute minimum. But when that pit stop actually begins, the very first physical action the plumber takes is incredibly easy to overlook.
Oh, right, the flush.
Yes, it's
Right.
critical to managing the system's physics. After the main cutoff valve is closed, they execute one final flush cycle on the old units.
Right, because if you skip that final flush, you are literally fighting the physics of the building.
Oh yeah, you're gonna have a bad time.
Because the pipes and the bowls are still holding pressurized water. The moment you unscrew an old valve, all that trapped potential energy just violently equalizes, right?
No.
Sending water straight onto the bathroom floor.
Yeah,
You basically trigger an instant flood.
exactly. And, if we connect this to the bigger picture, it really demonstrates how localized maintenance requires anticipating system-wide effects.
Every action has a reaction.
Right. Every action in plumbing has an immediate fluid dynamic reaction. The plumber is managing the potential energy of the grid before they ever even put a wrench to metal.
So smart. So that final flush drains the system, which finally reveals the failing hardware itself. And the source transcript notes these old valves have to be replaced because they're suffering from heavy corrosion.
Yeah, the plumber specifically calls out small pits building up inside.
Right, which we're talking about heavy brass and chrome components just being eaten away.
Well, municipal water is highly treated,
Mm.
and depending on the specific mineral hardness and chemical composition in a given region, it slowly degrades metal over time.
Even thick brass.
Oh, yeah. And pitting is a highly localized form of corrosion. So instead of the entire surface rusting evenly, these chemical reactions create microscopic cavities, literally small pits right in the metal.
And in a pressurized environment, those pits are fatal, right?
Yeah, fatal to the system's integrity because
Yeah.
the entire mechanism relies on incredibly tight seals.
Right, so that pitting means the rubber gaskets and internal components can no longer sit perfectly flush against the metal housing,
Exactly. Water under pressure will always find the path of least resistance.
even through microscopic pits.
Even those, which leads to constant, unstoppable leaking. And you can't just slap a generic pipe on the wall to fix it. Commercial setups require highly specific components to handle that kind of municipal pressure.
Right, and the terminology in the video is super specific. The plumber talks about the stops, which are those cutoff valves, and the flush tube, and the spud.
But a spud, right. That's the heavy tailpiece going down into the actual toilet bowl.
Yeah, and the escutcheons, which are those decorative trim plates against the wall.
Yep. The internal mechanics of these commercial flush valves, plumbers, usually call them flushometers, they are honestly brilliant.
Because they don't have a tank.
Right. They don't rely on gravity and a tank of stored water like a normal residential toilet. They rely entirely on the building's internal water pressure.
Oh, interesting.
Yeah, so inside that heavy chrome housing is a rubber diaphragm. Water pressure from the building pushes down on the top of this diaphragm, holding it firmly closed against the valve seat.
So the water pressure is literally being used against itself to keep the valve shut tight.
Exactly. It's so clever. When you push the handle, you aren't like manually lifting a heavy plunger or something. You are just opening a tiny bypass valve that bleeds off the water pressure sitting on top of the diaphragm.
And without that downward pressure, the high-pressure water waiting underneath the diaphragm suddenly has the advantage.
Yes, it lifts the diaphragm up, and a massive volume of water rushes directly from the municipal line straight down into the bowl to execute the flush.
And then it resets.
Yeah, there's a tiny pinhole in the diaphragm that slowly lets water refill the upper chamber, which rebuilds the top pressure until it just forces the diaphragm back down, cutting off the flush.
Wow. It's like a beautifully balanced tug of war using fluid dynamics.
It really is.
But looking at all these parts in the transcript, acting as the proxy for you, the listener, a massive question just hit me.
Oh, what's that?
Wait, if the water from the building goes directly into a commercial toilet bowl, what stops the dirty toilet water from just flowing backward into the clean drinking water supply?
Yes, that is probably the single most critical safety question in commercial plumbing.
I mean, it seems like a huge design flaw.
It would be, and it's the exact reason this trade is so heavily regulated. The source actually highlights a hidden component sitting right behind the flush tube called the vacuum breaker.
The vacuum breaker, okay.
Yeah, to understand why it's necessary, you have to consider a scenario involving back siphonage.
Backside, okay.
Imagine a water main breaks down the street. Or, say, fire trucks hook up to a hydrant just outside the retail store to fight a massive fire.
Right, so those fire trucks are drawing an immense volume of water from the city grid.
Exactly, which
Wow.
creates a sudden massive pressure drop inside the retail store's plumbing system.
Oh, I see.
And a pressure drop that severe creates a Venturi effect, an aggressive vacuum that starts pulling water backward through the building's pipes.
Whoa.
Yeah, so if a commercial toilet bowl is full of contaminated water and the flush valve happens to be open, or maybe it's leaking during that exact pressure drop.
That vacuum will suck the dirty water right out of the toilet bowl.
Yep, backward through the pipes and straight into the building's drinking water supply.
Oh my God. So someone getting a drink from the water fountain down the hall would literally be exposed to raw sewage.
Exactly. It would be a catastrophic contamination event.
That is terrifying.
It is, but the vacuum breaker prevents that entirely. It sits elevated in the chrome assembly, physically separating the clean supply from the bowl.
Okay, how does it work?
It basically functions as an atmospheric vent. If a vacuum ever occurs in the supply line, the suction immediately pulls down a lightweight plastic flap inside the breaker.
And that opens it up.
Right, it opens a vent to the outside air, so the vacuum pulls harmless ambient air from the bathroom into the pipes instead of sucking up the heavy contaminated water from the bowl.
Wow. By introducing air, it literally breaks the vacuum.
Exactly, it's a purely mechanical, fail-safe safeguard.
That is amazing. Every time we see one of those shiny chrome pipes in a public restroom, there is life-saving fluid dynamics technology just hiding right in plain sight.
Yep. But, designing this complex pressurized system isn't just about the mechanics of water.
Right.
It's also about adhering to strict legal and physical parameters. There's this constant tension between making the facility accessible for everyone while keeping the infrastructure safe and secure.
Yeah, that brings up the tools, right? You might think plumbing is purely brute force, just swinging heavy hammers and wrenching on thick pipes.
That's the stereotype, yeah.
But the toolkit detailed in this transcript demands an incredible amount of finesse. Like, the source introduces a highly specific tool for this job called a split wrench.
Oh, yeah, the split wrench. A standard pipe wrench has heavy serrated steel teeth.
Right, to bite into the pipe.
Exactly, designed to bite into galvanized iron pipes for maximum grip. But if a plumber uses a standard pipe wrench on a highly polished chrome flush valve,
It's going to instantly gouge the metal.
shred it completely.
And the split wrench specifically has no teeth.
Right.
The jaws are completely smooth, which obviously protects the aesthetic finish so the hardware looks clean in a retail environment. But scratching the chrome is actually much worse than just an ugly cosmetic issue, isn't it?
Oh, much worse. Gouges and deep scratches create immediate structural vulnerabilities.
Oh, so?
Well, they form microscopic valleys on the surface of the hardware. And in a public restroom, moisture, condensation, and heavy chemical cleaners like ammonia or bleach, they can pool and stagnate in those scratches.
Oh, right, because it's a harsh environment.
Exactly. That stagnant moisture accelerates galvanic corrosion, which invites the exact same pitting and degradation the plumber is currently there to fix in the first place.
It's a vicious cycle.
It really is. So the smooth-jawed split wrench allows the plumber to apply massive torque to seal the pressurized fittings, but without compromising the integrity of the chrome finish.
But sometimes that smooth hardware presents a pretty frustrating obstacle.
Yeah.
Which leads to, honestly, my favorite mechanical insight from the entire transcript, the dual wrench trick.
Oh, the improvised brace? Yes.
Yeah, so the plumber needs to remove the old corroded spud, which, again, is the heavy tailpiece connecting the flush assembly down into the actual porcelain of the toilet bowl.
That's been sitting there for years.
Right, it's deeply calcified, and the inside of the fitting is relatively smooth.
So the plumber can't get a solid grip to stop the spud from spinning while they attempt to loosen the massive locking nut on the outside.
And if the entire spud spins inside the porcelain, you can't break the compression seal.
Nope. And even worse, if you apply too much rotational torque to a stuck fitting inside a ceramic toilet bowl,
You'll crack the porcelain.
exactly, you easily crack the porcelain, instantly turning a standard valve replacement into a total toilet replacement.
Which ruins the whole timeline we talked about.
Entirely.
So the plumber improvises this internal brace. They take the rubber-coated handle of one pair of channel lock pliers and literally jam it directly down inside the hole of the spud.
Such a great trick.
Right, the rubber wedges in tightly against the smooth inner walls, giving them the leverage to hold the entire spud completely stationary.
Yeah.
And then, holding that first pair of pliers as an anchor, they use a second pair of channel locks to grab the stubborn nut on the outside and break it loose.
It perfectly demonstrates the localized problem solving that defines skilled trades.
Absolutely.
I mean, you were given a standardized toolkit, but every single job introduces non-standard variables.
Yeah, nothing ever goes exactly to plan.
Never. The ability to look at a pair of pliers and realize, hey, the rubber handle is the exact right geometry to act as an internal friction brace. That is the difference between keeping the project on schedule and totally failing the timeline.
So what does this all mean? It means commercial plumbing forces technicians to operate at the intersection of heavy-duty industrial assembly and surprisingly delicate craftsmanship.
Well said.
I mean, you have to measure a 1-inch copper pipe to fit perfectly inside a 1 78-inch flush tube. You have to carefully wrap threads with a specific thickness of Teflon tape to hold back massive municipal water pressure.
Don't forget the tiny screws.
Yes. After wrestling with heavy channel locks, you have to use a tiny, delicate screwdriver to tighten a minuscule set screw. locking the decorative trim plates, the escutcheons, perfectly flush against the drywall.
Yeah, the environment demands industrial precision, but it operates under really chaotic, real-world constraints. The hardware itself is beautifully engineered to be serviced quickly, utilizing standardized, exposed connections.
Right, everything is right out in the open.
Yeah, so a maintenance worker can swap out a failing diaphragm or a leaking stop valve without needing to tear open the wall. Accessibility is a deliberate design feature.
Well, here's where it gets really interesting. Because that tension between public accessibility and public safety comes back to bite the facility managers.
Oh, big time.
The very design that makes this hardware safe, efficient, and easy to maintain also makes it incredibly vulnerable.
Right.
The transcript drops a completely unexpected detail right toward the end. These heavy industrial commercial flush valves are frequently stolen.
It's wild to think about.
People are literally walking right into retail restrooms and stealing the plumbing directly off the toilets.
I know, it sounds like a bizarre prank, but if you analyze the design logic, it reveals exactly why it happens.
Because it's so accessible.
Exactly. Because the system relies on exposed, accessible connections to minimize maintenance downtime, it creates this unintended opportunity.
Wow.
A person with a basic wrench, or honestly, even strong hands, if the nuts weren't properly torqued by a professional, they can simply shut off the local stop valve, unscrew the heavy brass and chrome assembly, throw it in a backpack, and just walk out the front door of the retail store.
And they aren't stealing them to, like, build a high-pressure bathroom at home.
No, they are stealing them for the scrap metal value of the raw brass and copper.
That is crazy. It's an escalating arms race between the mechanical engineers trying to make maintenance as frictionless as possible and the facilities managers trying to prevent their vital infrastructure from being fenced at a local scrapyard.
Yep. The source notes that because these flushometers have been heavily targeted by thieves lately, facilities are actually forced to adapt their infrastructure.
How do they stop it?
Well, they're retrofitting the systems by purchasing and installing special secondary security locks.
Oh, like a physical barrier.
Yeah, these locks physically clamp over the connection points, requiring specialized keys to access the nuts.
But wait, doesn't that entirely negate the original design goal of quick, tool-free accessibility for basic maintenance?
Yes, it absolutely does. It completely undoes the accessibility they engineered in the first place.
Wow. And speaking of accessibility, there's another layer to this, right? The ADA standards.
Right. The Americans with Disabilities Act. The transcript explicitly mentions that one of the 4 toilets being worked on is designated as an ADA-compliant toilet.
So the plumber has to be extra mindful there.
Extremely mindful. Plumbers don't just bolt hardware to the wall wherever it fits best. They are bound by incredibly strict federal guidelines governing accessibility.
Oh, so like exact measurement.
Exactly. The plumber is calculating precise geometry while wrestling with this heavy brass. They are measuring the exact height of the flush handle from the finished floor to ensure someone in a wheelchair can reach it comfortably.
Right.
They have to ensure the handle requires no more than 5 pounds of force to operate.
Wow, 5 pounds.
Yep. And it can't require tight grasping, pinching, or twisting of the wrist.
That's a lot to keep in mind while you're racing the clock.
It dictates the clearance space around the unit, the torque applied to the internal diaphragm to ensure an easy push, and even which side of the toilet the handle must be located on, depending on the stall layout.
That is fascinating. It is literally a rigorous adherence to civil rights law translated into physical infrastructure.
Exactly. You are building a system that serves the entire spectrum of the public equitably.
The push and pull of all these factors is just relentless. So, to synthesize this deep dive for you, the listener, what started out as a raw, unpolished YouTube transcript about swapping parts on a commercial toilet really revealed a surprisingly intricate world.
It really did.
We saw how plumbers execute a high-stakes, time-sensitive prefab strategy to prevent a total retail shutdown. We explored the fluid dynamics of internal diaphragms and how that critical vacuum breaker physically severs the connection to protect our drinking water from back siphonage.
A literal lifesaver.
Absolutely. We unpacked the precise ADA regulations governing the physical space and the delicate toolkit, like the split wrench required to protect pressurized chrome. And ultimately, we uncovered the paradoxical loop of infrastructure design. Making something safe and maintainable for the public inherently makes it vulnerable to that very same public.
Yeah, the theft issue really highlights that. And I think the most enduring takeaway is that the next time you step into a commercial restroom, you are going to see that infrastructure through an entirely new lens.
Oh, for sure. I know I will.
You won't just see a metal pipe disappearing into a wall anymore. You will recognize the cutoff stops isolating the water pressure. You'll appreciate the decorative escutcheons hiding the complex drywall cuts.
Right.
And most importantly, you will look for that tiny vent on the vacuum breaker, knowing it is standing guard, keeping the entire building's water supply safe from a catastrophic pressure drop.
It really forces us to view the built environment with a little more respect. And, leaves us with one final lingering question to think about.
What's that?
Well, if a component as absolutely critical to our public health as a vacuum breaker is sitting right out there in the open, and the entire flush valve assembly is engineered to be so easily dismantled that random people are just shoving them into backpacks for scrap metal, how much of our everyday vital public infrastructure is simply relying on the honor system?
That is a very unsettling thought.
Right. We expect the water to flow, and we expect it to be clean. But maybe the real triumph isn't just the engineering. Maybe the real triumph is that this fragile, highly pressurized grid survives our daily interactions with it at all. Catch you next time.